Hello everyone. In the previous session, we have started the introduction of pointers. In that video, we discussed what a pointer is. After that, we have seen the syntax for declaring a pointer. We can declare a pointer to integer or a pointer to character or a pointer to float or a pointer to double. But all the pointers are going to take the same size. If an integer takes 4 bytes of memory, then all the pointers which are pointing to different data types are also going to take the same size 4 bytes. Why? Because pointers always store only the addresses. Addresses are always positive integers. So that's why all the pointers variables are going to take the same size. And we discussed that by using pointers, we can directly access the memory. In continuation of the last session, we are going to discuss pointers more elaborately. In this session, mainly we are going to talk about pointer to pointers, pointer to pointer to pointer, right? And various other types of pointers we are going to see. So first, let us see what is mean by a pointer assignment. First, we are talking about pointer assignment. See, we have taken an array, assume that integer a of 10, any dimension you can take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the values in the array. Now we are declaring a pointer integer star p comma star q. I'm declaring two pointers here. Here I'm saying p equals to a and q equals to p. We can say like this. So what do you mean by p equals to a and q equals to p? When we declare an array integer a of 10 equals to some 10 values, we know the memory representation is like this: 1, 2, 3. The elements I'm going to store here is 6, 7, 8, 9, 10. And we know every memory location is having its own address. Assume that this is 100, 104, 106, sorry, 108, 112, 114, 118, like this, and so on. Why? Because the addresses are 100 and 104. Why? Because an integer takes 4 bytes of memory. So that's why it is incremented by 4. See, at the time of discussing arrays, I said that the array name A consists of the base address or starting address, or it is similar to ampersand of A of 0. In this case, when you say P equals to A, the meaning is it is ampersand of A of 0, right? So this array is stored in the stack. Already we know stack memory. And also we have pointer variables P and Q. These are also stored in the stack memory. And assume that this is the variable P and this is the variable Q, right? P equals to what I'm saying A. P equals to A means what is the base address here? 100, or ampersand of A of 0. Here it is 100. That means the P is pointing to first memory location or the base address 100. P equals to A is like this. Now Q equals to P means that Q also storing the value P. P how much? 100. Now Q also pointing to the first memory location. This is the way of assigning the pointers, one pointer to another pointer, right? Now when we say when we printf percentage d, some value we want to print. If I write star p, we are going to get the value 1. When you write printf percentage d double quotes close star q, here also we are going to get the same value 1. By using P and by using Q, both are pointing to the first memory location, and we can get the value 1. Now another important thing is, here I am saying that P equals to P plus 1. I am writing P equals to P plus 1. In this case, what happened? P equals to P plus 1 in the sense P pointing to the first memory location, right? That means 100. Now P plus 1 means from P starting position, we are moving ahead one position. That means from 100 base address, we are moving to the next location. P equals to P plus 1 means the P is going to point to the address 104. Right? When we write here star P, then we are going to get the value 2. And the address it is going to contain is 104. That is very, very important. So adding some integer to the pointer indicates that the number of positions or the number of locations we are moving further. And the addresses are different. Why? Because an integer takes 4 bytes, then the next address would be 104 and next address would be 108. So this is the way of accessing the elements, or we can add an integer to a pointer, then it points the next memory location. Now after this, we are going to talk about what is meant by a pointer to pointer. Pointer to pointer. A pointer to pointer is declared like this, same as a pointer. Write any data type, integer star. You also add star, 2 stars. So 2 star indicates pointer to pointer, 3 stars indicates pointer to pointer to pointer. As the number of stars increases, the way we use pointer to pointer, the pointers concept also increases. Integer star star PTR. This is the way of declaring pointer to pointer. That means PTR is the variable which consists of the address of another pointer. So how to use this pointer to pointer? Let us have the discussion here. For example, we have the variables like this: integer a equals to 10 and integer b equals to 20, right? And now we are having the pointers integer star ptr1 is equals to ampersand a, and we are using another pointer integer star ptr2 is equals to ampersand b. And next we are using another variable integer star star ptr3 is equals to ampersand of ptr1. Next we are using another pointer to pointer star star ptr4 is equals to ampersand of ptr2. Right? How to represent this? See here, the value of a here is, here I am writing, this is a and this is b. What the a value 10 and the b value is 20 here. Every memory location is having its own address 100. Assume that this is 200. Now ptr1 is another pointer variable. This is ptr1. The name of this variable is ptr1 and this is ptr2. ptr1 equals to ampersand a, that means it is containing 100. ptr2 ampersand of b, that means it is 200. And this is having its own address 300. Assume that this is 400. Now ptr1 is the pointer to a and ptr2 is the pointer to b, right? After this, assume that we have another two variables like this. This is ptr3 and this is ptr4. ptr3 equals to ampersand of ptr1. How much? This is 300 and this is 400. It is also having its own address. Assume that 500 and 600. Here ptr3 double star means it is a pointer to pointer, means this pointer ptr3 is pointing to this location, which that means it is pointing to ptr1, which is again a pointer to a. Now ptr4, it is a pointer to ptr2, which is again pointing to b. So this is the concept of pointer to pointer. Now for example, if you use printf and percentage d a, then what is the value we are going to get? 10. Now another way to get this value is percentage d comma, here you can use star of ptr1. Here also we are getting 10. Okay, another thing you can get the a value is percentage d. You can also use star star double stars, double indirection operators of what do we say, ptr3. Here also we can get the value 10. Three methods. By using three ways you can access the value of a, by using direct to a or pointer ptr1 or pointer to pointer ptr3. Similarly, you can get the value of b like this. B, simply you can write b and printf percentage d, you can access the b value by using a pointer star of ptr2, and or you can say percentage d star of ptr4. These are the different ways to access the values of a and b. Here we have explained the concept of the pointer to pointers in detail. So now we are going to see the types of pointers. How many types of pointers are there? I will give the theoretical part. After that, we will see programming examples. Basically, we have various types of pointers. The first pointer we call it as null pointer, and second one is we have void pointer, and third one is we have wild pointer, and fourth one we have dangling pointer. What do you mean by a null pointer? For example, here I'm writing the variable like this: integer star ptr is equals to, directly I'm saying null. Means it is not going to point to anything. It is pointing to null. Null means we can't store any other address. Integer star ptr equals to null. This is called null pointer. What do you mean by void pointer? For example, here we are writing void star ptr, and we have declared a variable called integer a equals to 10, and here I am saying that ptr equals to ampersand a. We are storing the address of a, which is nothing but integer, into ptr, but we have declared ptr as a void. But whenever you want to print the value of a, for example, we are saying percentage d comma, here we are going to use the concept of typecasting integer star, and here I am saying ptr. That means ptr here is a void pointer. I'm converting this void pointer into integer pointer. So the main use of void pointer is that the void pointer can act as an integer pointer, character pointer, float pointer, or double pointer. But the thing you have to use is typecasting. Here we are using int star typecasting to convert this ptr void pointer into integer pointer, and it becomes the integer pointer. If you write star here, star of ptr, that means it is going to print the value 10. This is about the void pointer. What do you mean by a wild pointer? The wild pointer concept here is, for example, we are saying integer star ptr, right? But we are not going to store the address of any other variable in ptr, and we are using assume that printf percentage d, just we are printing ptr. So here we are going to get the segmentation fault error. Why? Because we have declared the integer pointer, but we didn't assign any address. The pointer which do not point to any address is called wild pointer. What do you mean by a dangling pointer? See, for example, this is the pointer which points to this memory location. Assume that this is the PTR which is pointing to this memory location, and some memory is allocated here. After allocation, assume that we have deallocated this memory. The memory is deallocated. Then, when the memory is deallocated, what happened? This pointer is pointing to only free memory space. Right? We have allocated some variable A. A has occupied this memory, and we have deleted the memory which is allocated to A. Now this pointer is pointing to the free space. Please remember, a dangling pointer is nothing but the pointer which is pointing to free space. So this is about the introduction about the various types of pointers. Now we will see how to implement these pointers by using Visual Studio Code. Let us go to Visual Studio Code. Now we will see the program implementation using pointers in Visual Studio Code. Let us go to Visual Studio Code, go to the new file, and you write pointers.c. Right here you write comments program to implement pointers. You write hash include stdio.h. Next you write int main opening brace. Here I'm using the variables integer a comma b. Right. Assume that we have given integer a comma b. Okay, now after this we have integer star ptr1 comma star ptr2. Okay, now we have integer star ptr3 comma star ptr4. Pointer to pointers also we are going to implement. Okay, semicolon. Now after this, assume that we have given A value 10, B value some 20. Okay, now we are saying that PTR1 is equals to ampersand A, PTR2 equals to ampersand B, right? Next you say PTR3 is equals to ampersand of PTR1, and you say PTR4 is equal to ampersand of PTR2, right? Now, in how many ways we can print the values of A, B, and we are going to print the addresses as well as the values also, right? Now, for example, here I'm writing printf. I'm going to say printf. Here I'm writing the value of A is the value of A is, here I'm writing percentage D slash n double quotes close comma. I'm writing different ways to print the value of A. This is one, directly we are printing the value of A. After this, what we are going to see is Control C, and here Control V. The value of A is percentage D. Here we can use the notation that star of, what I'm saying is ampersand of A. This is one method. Okay. Next, another method I'm going to use here is, just wait, comma. What you do is you write star of PTR1. This is one method. Now another method here is I'm going to use star of PTR3, right? So there are four methods to print, four ways to print the value of A. Directly we can print A and star of ampersand A, star of PTR1, and star of PTR3. Now similarly, how to print the address of A? In how many ways we can print the address of A, right? Here I'm going to copy the same statements. Here I'm printing Control V. Here the address of A, we are printing the address. How to get address of A? Address of A is, here I am using P. Why? Because to print the address in a hexadecimal, I am using P. The address of A is given as ampersand of A. This is one method. Next, the same thing I am going to copy here. Another way is Control C, and here I am writing Control V. The address of A is percentage %P, and here the address is stored in PTR1, right? Just I am writing PTR1. Same address we are going to get. By using ampersand A, we will get address, or directly we can say PTR1. Now, another method here is, we can also get the address. Here I am writing Control V. Here also you write slash P, slash N, here you write. Now, the address of A is P, and here PTR1. PTR1 value is, here we can say star of PTR3. If I say star of PTR3, you can get the address star of PTR3. In how many ways we can get address? In three ways, right? You delete it. So there are three ways to print the address of A: ampersand A, PTR1, or star of PTR3. The same thing you can do for B. Control C, and I'm writing here Control V. Now you do one thing. Here the value of B, I'm going to do some modifications here. You write B, here you say B, direct we can get B value. Now here also you write B, So here you can say B. In place of B, just I'm writing. Now the value of B, here I'm writing the value of B. Here you can say star of the value of B is percentage D star of PTR1, but here you have to say star of PTR2. Next, the value of B here is percentage D, comma star of PTR4, star of PTR4. Now the address of B here, B, just I'm changing A to B, and here you write B. Next, the address of B here, P, and here you write PTR2, PTR2, and the address of B here is star of PTR4. Okay, we'll see whether we are going to get the same result or not. Return 0. So we are using different methods to print the output. Control S and you write, run it. Semicolon is missing. Okay, we will see where is the error. Here right parenthesis is there. Okay. Now here also one more right parenthesis. Control S. Now you run it. We will check whether there are any errors. Okay, see here. No errors. We got the output. You see here at the bottom. You observe this. See first. The value of A is 10. The value of A is 10. You see, we have printed 10 4 times, means we have used different notations. A value 10, A is 10, A is 10, A is 10, A is 10. See, address of A. We are getting same address in hexadecimals. 3 methods. We got same address, right? And B value 20. How many ways? 4 ways. Next, we have printed the address of B. We got same value. So this is the way of using the concept of the pointers and pointer to pointers. Okay, so execution starts from the main. Here A, B are ordinary variables, pointer 1, pointer 2 are pointer variables, pointer 3 and pointer 4 are the pointer to pointer variables. A equals to 10, B it is pointing to address of A and this is address of B, right? C, ampersand of A means address, star of address directly it is printing the value of A. Okay, I think already I explained the theoretical part. So this is the method to access the memory or the addresses or the values by using the concept of the pointers and pointer to pointers. With this, I'm going to close the session. Thank you for watching.